Hello, I would like to welcome everyone to the first integrated building design webinar of this year. And there will be a series of webinars that will be through the whole academic year. The first webinar will be focused in NoMad London, which is the latest example of a historic London icon revived and repurposed to give a new lease of life as a luxury hotel. This talk will give an insight into some of the design and engineering challenges faced when creating a high-quality and high-value hotel from 19th century public building. How do you achieve good in-room acoustics when guest rooms are sandwiched between bars, a nightclub, and plant rooms? How do you escape safely from your room in a fire when there is a labyrinth of corridors to navigate? These are some of the issues that the architects faced from the outset of the project. Hughes, which will be the person who will give the talk today, has worked as a mechanical engineer in the built environment for nearly 15 years, working with Lee from the last 10. His current focus is in the hospitality sector, which has been significant investment in the recent years, even despite the pandemic. A large chunk of Ian's time is spent on design and problem solving, which is one of the most enjoyable parts of the job. He also has a keen interest in low energy and passive building design, for which there are more and more opportunities to apply these approaches nowadays. This webinar will be recorded, and please write all your questions through the sessions in the Q&A section, and then we can have the Q&A time to discuss them. Ian.
Yeah, thanks very much, Athena. Thanks. As Athena says, my name's Ian Hughes. Work for an organisation called Hawley. So we're a multidisciplinary engineering consultancy. I'm a mechanical engineer by qualification, so that sort of tends to be my focus. But obviously, working on very collaborative projects, I tend to get involved in lots of aspects of projects. So thanks for having me here today to talk about NoMad London. So if we move on to the first slide, I've got about 25 slides, so hopefully we'll get through those on time. So as I said in the summary for the project, it was really about reviving an icon. So the building itself was formerly the Bow Street Magistrates Court and Police Station. It's a grade 2 listed building, and the project was about creating a 91 bedroom 5-star hotel in the centre of Covent Garden. It's got an extensive food and beverage offering, so that's including 4 cocktail bars, a big restaurant in the centre of the building, and 5 kitchens supporting that, as well as all the other features, back of house and bedrooms and so on. The cost of the project was about 38 million by the time it had finished, and it was procured over 2 contracts, so an enabling works contract and a main works contract. The building opened in May of this year, slightly later than originally planned, obviously because of the pandemic. But obviously that didn't get in the way in the end of it being completed. And it also was actually the winner very recently of the European Hotel of the Year 2021. So that's one of the it's known as the AHEAD Awards. So it's a very, very high profile, prestigious award. So great recognition of the success of the project. You can see us there picking up our award at the ceremony there. So in terms of the site and the context of where it's located, so it's pretty much in the heart of Covent Garden. So as you can see, the highlighted pink area is the building. So you've got the Royal Opera House almost directly opposite on Bow Street, and you've got, you're within a stone's throw of Covent Garden Market over here, and a short walk from the tube station. So it's very much a central part of Covent Garden. It's a building that's actually been empty for quite a long time before the refurbishment took place. So it's amazing really that you consider the location of the fact that it hadn't really been, taken advantage of before. So I thought it'd be worth just starting the presentation with a bit of history of the site, because it's very interesting history of this building. So the building was originally completed in 1881. and it was actually built as two separate buildings, but that were linked internally. So the split line was roughly to the right of, if I just get the pointer open, the split line was roughly in this position. So on the left-hand side, you had the Magistrates Court building, and then on the right-hand side, you had the police station. It was it's obviously grade 2 listed, and it was on the site originally originally home for the infamous Bow Street runners. So a bit more about the history of the project. So the Bow Street Magistrates Court itself has technically existed for over 260 years. So, and it's actually occupied a number of sites on Bow Street. So the first court was actually in a magistrate's house on Bow Street. And sort of in the mid 1700s, there was a big problem with gin consumption in Covent Garden and Westminster and the sort of wider area. So, and the associated sort of crime that was increasing because of that. And so one of the magistrates took it upon themselves, who lived on Bow Street, to create a group of constables, which went on to become known as the Bow Street Runners. So the Bow Street Runners were the first sort of really organised policing unit in Britain, and ultimately went on to become the first uniform policing unit, and eventually the Met. So this image on the bottom left here is actually a view down Bow Street, and you can see the Bow Street Runners in their get-up here. This image on the right was, I'm guessing, probably from around the 60s, just showing a motorcade of police vehicles coming into the site. And you've also on the left here, you've got a view of the original courtroom. So probably from around the 1700s as well, this image. And then in the middle here, we've got a view of the main entrance into the original court building. It was quite common when there were high-profile court cases for all the reporters to congregate outside, so waiting for people to come out at the end. And I think if you go down there now, there's a row of old red phone boxes which have been retained, and they were installed sort of before the days of mobile phones, so reporters could quickly get to get news back to the newspapers. The court itself has been home to a lot of high-profile court cases. So this image on the bottom left here is just a selection of some of the people that have been on trial or attended court cases. So people like the Cray twins, Jeffrey Archer, Oscar Wilde, Vivian Westwood, and so on. And as you can see, there's some other sort of interesting historic pictures. So the protest of the suffragettes just outside the building. You've got a photo here of the main courtroom, which is probably from sort of early 20th century. The building itself was, as I said, was finished in 1881, so was operating as a court and a police station all the way through to the early 2000s. Up here there's another image of the Bow Street Runners, or the sort of early Met police force that would have worked from here. So in terms of the project brief, and what we were asked to do. So really the sort of the client's focus on this when we got involved at the outset was about trying to revive a historic building and create a bit of a new focal point in Covent Garden. What they wanted to create was a high quality luxury hotel, with really food and beverage and food and drink being the sort of heart of the offer. And really differentiating itself in that sense. So, generally with these sort of projects, the food and drink is central to the whole thing. So it's really what tends to attract people into the venue. The bedrooms almost become secondary, and it tends to be where they make most of the money as well. And it was also just about creating a destination venue, so somewhere high profile, a place that people want to go and be seen and spend time. And it was also the first venture for the particular brand NoMad outside of the US. So for them, that's a really big deal. It's already well established in the US, but to take it out into the UK was really exciting for them. There's an image up here just of these two guys, Daniel Hum and Will Gadera. So they're quite famous restaurateurs from New York that were actually part of developing the original food and beverage brief. So we got to meet them on sort of early stages of the project, and it's quite exciting to get their input into the project. These images on the rest of the images are some photos of the finished building. So you can see the sort of, you know, from an interior design perspective, it was very, very unique, very special, the sort of atmosphere it creates. Yeah, and then in terms of the engineering challenge for us, so I mean, the key things that we took from the client briefing were that they wanted to try and maximize the number of bedrooms and public area space, but working within the constraints of the site. To work with a very fragile historic building, you know, listed buildings tends to make things very difficult, and you have to be very careful what you do, even with grade 2 listed buildings. And in terms of the delivery and procurement of that, the client wanted to get the building done within 3 years from concept to completion. So we were originally appointed in 2017, and the plan was to be open by 2020. Obviously, the pandemic kind of got in the way of that, but still, that's a very, very aggressive program when you compare it to a lot of projects, especially at this size and scale and complexity. So yeah, a real challenging project in that sense. So where do you start with a project like this? Well, the first thing that you've got to do is get a team together. So a project like this is a really, really good example of where collaboration is such a key part. You know, it's about bringing together lots of different designers and specialists to try and create something that is sort of greater than the sum of its parts. So it's all about getting lots of different people from different disciplines together and all pointing in the right direction and working together to sort of achieve the same goal. So the structure on this project was fairly typical of other sort of hotel projects. So you have a funder or someone who's willing to sort of stump up the capital to fund the projects at the top, and they'll appoint a developer. So in this case, Sidel, who was our client, and they sort of act as the sort of overall point lead for the project in terms of delivering it day to day. They were also the project manager in this case, which kind of made things a bit easier. They then appoint an architect and an interior designer to develop the sort of concepts of the scheme. So in this case, we had EPR architects leading the overall architecture of the project, and then an interior designer, Roman and Williams, who are quite a well-known interior designer in the US, developing the interior concepts, the look and feel of the spaces, how it flows. So yeah, two very high-profile, very competent designers working together and leading the rest of the design team. And then I guess in terms of the rest of the design team, and this is a sort of summary of probably the key designers. There's probably more organizations than this involved in reality, but these are the key ones. So you've got catering, which is a really big part of it, 2 different consultants and designers developing that. You've got IT and AV technology. You've got planning consultants. Our role in particular was to develop the MEP engineering, as well as a number of specialist areas, so acoustics, vibration, fire, lighting, sustainability, and lifts. And then you've got all the other usual roles like cost consultants, contract administrators, historic buildings for the listed aspect, and various other things. Ultimately, in terms of the build of the project, you've got a main contractor with, I think in this case, we had over 30 subcontractors because of all the specialist aspects of the building. So I guess the sort of big challenge with this is you've got a lot of people working on lots of different streams in parallel in a short space of time. So the challenge is trying to keep them all focused on the same thing, and managing change is a really big challenge, especially where you've got, you know, a sector where fashions and trends change quickly, and you know, even over the life of a project, the client's desires and brief can change. So trying to manage that and keep everyone up to speed was a real challenge, but you know, we made it through in the end. So once you've got your team established, the first thing that we needed to do was to try and get a good understanding of the existing building. So that really meant initially spending a lot of time on site. So the building, once we started, was derelict. Essentially, it had been the court building had been unused since 2006. So yeah, and then the police building was even longer than that. I think the police station actually closed in the early 90s. So it really wasn't in a particularly good way. So yeah, a lot of time spent on site, walking around, taking photos, taking measurements, trying to get an understanding of what's going on. Obviously, I'll come on to it in a sec. There were some new build aspects to the project where we were extending and the building, but those parts tend to be easier to understand because you're working with a new design. But sort of the key takeaway from this project was that you need to have a really, really good understanding of the existing building before you sort of get into the detail of designing it. Because what you don't really appreciate looking at the scheme in 2 dimensions is how the levels work, especially in historic buildings where they tended to be up and down and all over the place. So that was a really important part of the project. I suppose the other thing as well is if you're lucky enough to have record drawings, then that can really help with developing your design, your understanding of things. So in this case, being a public building, there are a lot of archived record drawings, you know, to a very good quality as well, which had somehow survived since late 1800s. So I've included some images here of those, but we had hundreds of these, which really helped us get our head around things. So then, yeah, just to give you an example of how that works through into the design. So what we would tend to do is spend time on site, taking measurements, getting an understanding. So an example here, you've got a main corridor running down what would become one of the guest room floors. So we'd start by working up section sketches of what we need to get down there in terms of engineering and services. We worked that through into our design. In this case was a Revit model, and that materializes itself at the end in a working installation. And the great thing about this project is that it was such a short space of time to see it go from this to completion. So you know, it was quite satisfying in that sense as a designer to see things happening so quickly. Another really important part of the project as well, which really helped us, was we used what's known as a point cloud survey to help us with remote surveying and building our first model of the project. So this was in, I guess, 2017 when we started. This was carried out, and this sort of technology was reasonably well established, but I guess still in a sort of the early stages in terms of how it's used practically on projects. So I was just going to quickly jump out of the presentation to show you how that actually works. So what we actually did was we employed a company, a specialist surveying company, to go into the building and spend, I think it was about a week or two, with essentially a laser scanner going around all parts of the existing building, and they go away and process it, and they build what's known as a doll's house, which they then put online and allow us to access. So the great thing about this is it's once we got going with the project, it massively reduced the amount of time we needed to spend on site surveying. So it's very similar to kind of a Google Street View concept. So essentially you get this doll's house, and you can look at things in a plan view, and then you can say, right, well, I want to go to let's say the 4th floor, or sorry, the 3rd floor even, and that'll cut down to that section, and then you can click into the zone that you want, and then this will take you to the part of the building you want to look at. So in this case, this is the original jail cells in the police station. So you can take a walk down the corridor. You can then go into rooms that you need to look at, see what the state of play is, and if you need to even take measurements, you can do that. So for example, you can click on here and take a measurement. So yeah, this was a really, really useful tool to have. It's something that we at the time we hadn't used on any other projects. I mean, just give you some other examples as well. If we go to the original ground floor, we can go into what was the courtroom. So as you can see, this was actually the original courtroom that was in that early historic photo. So you can see, obviously, at the time, they'd done some pretty horrible modifications to it. They'd actually installed a secondary ceiling because there was a glass roof light over the top of this that used to cause a lot of overheating. So they'd put this false ceiling in with lots of air conditioning, and put some pretty ugly acoustic paneling in. So this is how it was used as a functioning courtroom, sort of up into the early 2000s. And this is probably one of the focal points of the whole project. So it's now become an event space, but with all the original features kept. And when we pulled all of this paneling off, we found lots of interesting glazed tiling. So yeah, it's an amazing space to see in real life. So if I just go back to the presentation. So yeah, so obviously the outcome of doing this this point cloud survey initially was that we got this doll's house, which helped us massively. But following on from that, the surveyors then produced a mesh from the scan they'd taken, which enabled them to build a very detailed Revit model of the existing building. So what that ultimately led to was a fully integrated Revit model that included both the new build and the existing elements of the building. So this is actually a view of the architect's combined model. So what you can see is you've got the existing court building and then the police station wrapping around the front. And then you've got the new build extension on the back with a glazed atrium in the middle. And we also had a 3-story basement that goes down underneath to accommodate a lot of the back of house and plant support areas. So yeah, and I mean, an incredibly complicated Revit model, very difficult to work with because of the size of it and complexity. But ultimately, we couldn't have designed the building without it. It's the sort of design where if you hadn't have looked at anything in 3D and you got to site, it would have been a complete disaster because you needed to understand as much about things in the Z-axis as you did in plan as well. So this was a really important tool, and it's really informed the way we work on projects now as well in terms of our approach to using it. So moving on to, I wanted to sort of give some practical examples of where we used collaborative design and where we work with the different specialists and other parties in the design team to achieve ultimately something that was of high value to the client. So as a first example, this is a section through the existing court building. So when we came onto the project, it already had planning permission for a certain scheme, and that had been consented, I think, a year or so before we got involved. And one of the things, as I said earlier, the client was very keen to try and maximize the amount of space for bedrooms and public areas that we could get out of the building, because ultimately that's revenue generating space for them. So this was one of the architectural sections from the scheme that had been given planning permission. And this is the main courtroom that I showed you in the doll's house view, and directly above that, the intention was to have the sort of main energy plant room for the building, so where all the heating and hot water is generated, and then directly above that was a well, which was going to be for all the heat rejection plant. So really, all of this space was sort of obviously important, but not of particular use to the client. So we saw an opportunity there to try and do something a bit clever to try and maximize a bit more space. So moving on to the next slide, what we actually ended up proposing was keeping the energy center plant room where it was, but sandwiching an additional layer of guest rooms between the roof plant and the energy center plant room. So I guess there are a number of issues with doing that. The first one being that if we push all of this plant up on the roof higher up, then there's a potential risk of exceeding the planning limits. And there's also the fact that in a 5-star hotel, you'd expect these guest rooms to be almost whisper quiet, and to get the amount of money you'd be paying for these rooms, you'd expect very good in-room acoustics. So there was that challenge to deal with. So in terms of dealing with the plant, that was a fairly straightforward engineering solution that we managed to develop without having to make a significant change to the planning limits of the building. But what was more complicated was how we isolate this plant area from the occupied parts of the building. So how we actually did that. So this is a 3D view of the structural engineer's model. So you're showing a combination of steel and concrete. So this is the plant room in question, which is, so it's got lots of things in it that are noisy, like pumps, boilers, CHP engines, fans, all kinds of things that have, you know, tonal noise and vibration. So really the challenge was how do we, you know, in a cost-effective way, isolate that part of the building from the rest of the structure and prevent noise and vibration transfer to the other spaces. So in terms of looking at the detail of how that works, we've got, this is a section through that area again from our Revit model. So as you can see, you've got plants up at the top of the building, which is so there's fans, this is air conditioning equipment, heat rejection equipment, which obviously has vibration properties, and then we've got pumps, boilers, etc., all sitting in this area here. So the first thing that we had to do was look at how we can isolate this plant room floor from the rest of the building. So what that ended up being was the structural engineer's concrete slab with essentially another floor for the plant room to sit on an isolating layer in between. So what that looks like is these kind of rubber pads, and then all of the rest of the floor sits on top of that. And then directly above the bedrooms, where you've also got plants, so air conditioning units, air handling units, and so on, we've got a similar approach. So this is a section to detail through the architect's roof design. So you've got a very thick layer of insulation, which then gives you essentially a floating floor for all the plants to sit on. So you have a layer of screed, and then you have interstitial layers in between, which isolate that plant. In addition to that, what we also had was plants sitting on secondary support bases. So that's essentially a proprietary kind of pedestal system with vibration isolation mountings on all the kit. And yeah, essentially that is how you achieve minimize the amount of vibration and noise transferring through. I'm pleased to say it was effective as well. So it was always a kind of a nervousness that actually you're still going to have issues, because building this, designing it in theory is straightforward, but building it is a different issue. But obviously, it was fine in the end. So I guess the final part of that is actually how we validate that. So once all of the plant had been installed, once all the main structure and internal finishes had been installed and more or less completed, we had to get the plant commissioned and running so that we could simulate real life conditions. And then we spent a few days on site with the contractor and their acoustic specialists. So going around with acoustic, vibration and noise detection equipment, and we measure what noise levels and what vibration levels we achieve in the rooms, and then essentially say whether or not the room is achieving what was in the original design intent. If it is, then great. If it's not, then the contractor goes away and has to correct whatever's gone wrong with the installation. So that was all quite an interesting part of it as well. The sort of second thing I wanted to talk about was about fire safety. So I guess before I go on to that, it's probably worth saying that there's a lot of technical complexities to delivering this building, and I could probably speak about it for hours, but I've sort of chosen fire and acoustics because they're probably the two most interesting. So yeah, as I said, fire safety was probably one of the most complex parts of the design of the building. So it's if you imagine that the layout of the building internally is incredibly complicated, and if you imagine that it's a 5-star hotel, your expectation when you arrive is that it's a welcoming space, it's comfortable, it's easy to get around. You're not going to be familiar with your surroundings, so wayfinding needs to be intuitive and have as little restriction as possible. But obviously at the same time, we need to make sure that we're complying with building regulations, that we're achieving, all the various standards that you would expect of a high profile hotel. So it's really, and from an engineering perspective, it's trying to find a balance between, those things and justify how our approach works. So what I thought would be worth doing is just considering a sort of real life example. So this is a view of the building from Bow Street, sort of looking north. And you've got what was along here was the existing jail cells at the back of the police station. So this part of the facade was retained, and then the sort of 3 stories above that were built as a new extension for guest bedrooms. So if you imagine in this situation, you've got on the 3rd floor, you've got a bedroom right down the far end of the building, and a fire starts in it. You've got all the other guests maybe asleep, so it could be 3 o'clock in the morning, this fire starts. Most people in the building are unfamiliar with the surroundings, and I guess, worst case, people may be intoxicated or, had a good meal out, and they're, in a deep sleep. So if I go to the layout of that area, so that particular wing of the building was probably the most difficult because it was the furthest from a safe escape position. So building regulations says that a hotel room should never be more than 9 meters from a safe point of escape. So if you want to derogate from that, you've got to have a very good reason why. So in this particular example, this bedroom here, it's right at the end of the corridor. The only way to facilitate a 9-meter escape in one direction would be to have an escape route out here, but there's nothing below here. So you'd have to build another story essentially to allow a door to be placed there to let someone out. So that wasn't going to work from a planning perspective or a rights of light issue, rights of light perspective. So yeah, in this instance, what you've actually got is a distance of about 17 meters. So that's the distance from, getting out of the bed in this room and getting down to this protected lobby. And then obviously, if you've made it as far as that, you've still got to then work your way out down through another lobby and then into a protected stair, down 2 stories, and then come out into another lobby where you've got multiple exits. So following all the illuminated signage, you make your way out and it brings you out onto the street. So yeah, so when you going back to this view, it looks like it's not that far, but actually, if you imagine you've only been there for a night, you don't know the building layout that well. It could be slightly different. So from an engineering perspective, there's ways that we can get around these sorts of challenges, and this is sort of where fire engineering becomes a really integral part. So in terms of how we actually achieve that, again, this is the layout I was just talking about on the 3rd floor. So if you imagine a situation where you've got guests staying in this bedroom, perhaps they've come back late, one of them decides to light a cigarette, even though they're not supposed to, puts it down, forgets about it, goes to sleep, cigarette falls on the floor, sets fire to the carpet or the curtains. Believe it or not, that's actually one of the most common ways for fires to start in hotels. So that fire starts, and let's say it's 3 a.m. So the first thing that happens is the smoke from that fire gets detected by one of the smoke detectors in the room, and it sends an early warning signal down to the main fire alarm, which is monitored 24 hours a day by the FM team. So being a 5-star hotel, what you don't want to happen is lots of nuisance fire alarms going off all the time, disturbing people, getting people out of the building when they're fast asleep. So in this case, what we had was what we call a double knock system. So if a fire is detected, the first signal that's sent to the fire alarm is purely an early warning signal that goes to the FM team, and no alarms go off. And then once that alarm signal is sent, there's a roughly 3 to 5 minute period where the FM team have a chance to go and investigate. So they'll get a signal from the fire alarm saying, they're saying there's a fire in room 301, you need to get up there to have a look. So they go up there, and then if in that space of time there is a real fire, then the chances are the smoke from that fire will spread, and activate another smoke detector. So once that happens, it's confirmed that it is definitely a fire. If the FM team get there and it isn't a fire, then they can then go back, disable the fire alarm, and everyone can stay where they are. So once that second detector's gone off, it's then confirmed as a fire. The fire alarm goes off, and in theory, everyone should wake up. So then the next thing to happen after that is that obviously if you've got smoke that's developing from an early stages of fire, that smoke will spread to anywhere it can. So if you've got a ventilation system that's serving multiple rooms, what you don't want is that smoke spreading through the ducts and coming out into another room where there might be someone who's still half asleep working out what's going on. And before you know it, their room's full of smoke as well, and they can't find their way out. So what we do is we put dampers in the ducts that automatically shut, stop the smoke spreading through. So that happens instantly when the fire alarm goes off. So by this point, the dampers have shut, and the people in the original fire have probably escaped out the room, and other people are starting to wake up and escape down the corridor. Now, when these people leave their bedroom, there's a good chance that if the fire's getting underway, the smoke will spill out of that door and into the corridor. So what we don't want to happen is all of that smoke to build up and start blocking everyone else's way out, or in worst case, causing them to inhale lots of smoke. So what we do is we have an automatic opening vent at either end of the corridor, and that automatically opens and lets any smoke that builds up in here spill out to outside of the building. So by this point, most people are probably awake and out and running down the corridor and into the escape stair. And the fire brigade unlikely to have arrived by that point. So the fire's growing, it's getting hotter. So as the temperature rises of that fire, it will automatically set off a water mist system. So rather than using sprinklers, which need lots of space and cost a lot more money, we managed to justify using what's called a water mist system. So that works in a very similar way to a sprinkler system, but it sprays a very fine mist of water rather than a sort of sprinkle of water. So once that goes off, that will very quickly reduce the temperature of the fire and in theory stop it from spreading any further than the room. And then in a worst case situation, if the fire isn't extinguished, the walls around the room are rated to 60 minutes. So that will prevent the fire spreading out of that room within that time period. And you'd expect in London, the central London, for the fire brigade to have made it to that building well within that time. So that's how we can justify doing that. The only other thing to say, I suppose, is that we also have AOVs in the protected stair. So once people make it into here, there shouldn't be any smoke. This is a completely sterile environment. And then, obviously, once they're into the stair, they can make their way down and out into safety. So, yeah, I mean, this is just one part of the building, and there were lots of other areas where we had not the same approach, but probably the same level of complexity. So, engineering systems essentially facilitating an arrangement that wouldn't traditionally be compliant with building regulations. So, yeah, really interesting from our perspective to be able to develop this sort of strategy, and ultimately it's what's allowed the client to get more rooms out of an area that they theoretically wouldn't have been able to without that strategy. So I mean that's really the end of the presentation. I thought it might be worth just adding as well for anyone that's interested. There is actually a museum in the building. It's about the history of the London police force actually built the Met. But if you get the chance, it's definitely worth going down, and it's actually set in the original jail cell, so you can see what they were like and experience them. The other thing I was going to suggest as well is that if you've got Netflix, there's a series called 7 Days Out, and the first episode of that series is set in 11 Madison Park, which is a restaurant in New York that was started by the restaurateurs that were involved in NoMad, and it's essentially about the 7 days in the lead up to the opening of the restaurant, and there's a lot of parallels with the opening of a hotel like this in terms of the rush to get things done, the sort of hurdles and pitfalls of things not working and commissioning not going properly. So it's an interesting watch and sort of gives you a flavour for how important a lot of the engineering is for a building like this. Yeah, so that's the end of the presentation, really. I think, Athena, we can go into the Q&A if there's anything.
Thank you, Ian, for your presentation. And we have already 2 questions.
Okay.
One is from Sam Stamp. Did you have to apply other acoustic measures to the other bedrooms, given what you mentioned about expectations for noise in 5-star hotels and the Cindy Center location?
Yes, we did actually. So yeah, that's a good point. So the original building obviously is grade 2 listed, and I'd say probably about at least 50% of the rooms and the suites were in the existing building. So being listed, we're sort of limited on what methods we can apply to deal with noise. So one of the things we did was to add secondary glazing where the buildings front onto the roads in particular, because obviously we couldn't touch the existing single glazed units on the bedrooms. So we put in secondary glazing in those, which helped us to achieve the in-room acoustics. I mean, in terms of other measures that we looked at, so on the mechanical systems, there was noise attenuation applied to things like fan coil units on ductwork that shared between multiple rooms. There's also the sort of architectural side of the acoustics. So doors are very heavily rated to stop noise transfer from corridors. I mean, if anyone's ever stayed in a hotel, it's quite often the case that nuisance noise from corridors is the sort of thing that wakes you up at 2 o'clock in the morning, someone drunk coming back, from a night out. So that's a key part of a hotel like this, is that's completely unacceptable to have that happening. So doors and wall ratings are appropriately designed to make sure we don't get that. And interestingly as well, the other thing that we design in is a certain amount of soft furnishing, so we can actually model the impact that things like curtains and carpets and finishes and so on have on the reverberation in a space. So all of that, input from the interior designer gets modeled to make sure we're achieving the right requirements. I think that's probably the main thing. I mean, the only other thing was looking at isolation of where you fix services and equipment to the building structure, how you isolate it with things like spring mounts and so on. So that's all fairly straightforward, but it's extra complexity and cost that you wouldn't necessarily always have to do. Hopefully that's answered that.
And from Anna Mavroyani, thanks Ian for the excellent presentation. What would you say were the biggest challenges of collaborative design with such a large multidisciplinary team?
It's difficult to say what the single biggest thing was in terms of the biggest challenge. I mean, from my personal perspective, I think one of the biggest issues we had, or one of the things we sort of underestimated, was just how complex the services installation would be. And I think even when we worked through the design, we knew it was complicated, but once we actually got onto site, it was even worse, because you're working with an existing building where, even though you've got a reasonably accurate Revit model, there were still quite a few unknowns. So there was a lot of hidden structure that we didn't know about, because they modeled parts of the building before they'd been able to soft strip. So there'd be situations on site where you'd have a primary services route clashing with a major structural beam that we didn't know was there. So having to kind of work out solutions in a matter of hours or days was really challenging. One of the things I haven't mentioned as well is the kitchens. So as I said, there were 5 kitchens in this building. So the level of engineering and servicing that goes into a commercial kitchen is generally very high. And these kitchens were sort of all kind of shoehorned into corners of the building that were quite far from the outside of the building. So trying to get ventilation ductwork away from them, which is really big, it was incredibly problematic, with all of the air treatment that you need to put into it, and all the noise cancelling and so on that you need to provide to make sure you don't upset the neighbours. That was probably a big part of it. But I guess the original question was about, in terms of collaboration as well. And I think, thinking back to how it worked, You know, we had a multidisciplinary team, and the interior designers were based in the US as well. So that made things quite difficult because we never really got to meet physically. And this was kind of before the pandemic, when remote working had become more well established. So yeah, working with those guys and with the architects, all trying to sort of reach a coordinated design, all at the same time as things changing on a regular basis. You know, that was really difficult for us, trying to keep up. You know, that was a really challenging part of it as well. Yeah, I mean, I could go on for hours, to be honest. There's so many other bits that were tricky as well. But I think, you know, I think the challenge with it was time. I think if you had more time, it's a bit easier to kind of pull all these things together. But when you've got so many different people working together in a short space of time, it takes a long time to communicate things, you know, and disseminate things. It's easy for people to fall behind and, you know, be working to historical information. So yeah.
Thank you so much. We have 3 more questions.
Sure.
Okay, the first one, again from Anna Mavroyani. Thanks for the detailed description of the fire safety plan. What are the main design conflicts between fire safety requirements and ventilation strategy for this type of building?
Well, I suppose there are a few different aspects to this. So from a ventilation perspective, on the upper floors, so the guest rooms where I showed you the worked example, that was a bit easier because what you can do if you need to ventilate corridors and escape routes, you can generally do that with a direct opening in the wall to outside. So that's fairly straightforward to deal with. And equally, as I said, where you've got ventilation systems that cross over between 2 rooms, you can put dampers in to stop smoke from spreading from one space to another. But I think where it became more complicated was down in the basement. So we've got a 2-story basement with a 3rd smaller story that goes down under the plant areas to accommodate all of the water storage and that kind of thing. So in that instance, you've got a basement that's very deep underground, and is quite a long way from outside of the building. So what we had to do in that case was provide a smoke control system. So in the event of a fire in the lowest story of the basement, we put in a dedicated smoke extract system. So that is a fully fire rated and smoke rated system that can extract smoke from the room that contains the fire. And that works in conjunction with the water mist system that I mentioned earlier. So the idea being that so every room in the basement is compartmented into a fire zone. So if a fire starts in one of those rooms, it can't physically spread outside. But because you might have a situation where for whatever reason someone may be trapped down there, or the fire brigade take a long time to get down there to put the fire out, what you can't do is let that smoke build up, because once it builds up to a dangerous level, it's going to make it untenable for the fire brigade to actually get down there and put it out. So what we do is we have a system that is sort of a dual function system that normally works as a ventilation system for the basement, but when a fire starts, the system switches over into a different mode. It isolates the room with some control dampers and then extracts smoke from that zone during sort of first hour or 2 of the fire, and then that allows the fire brigade to get down there to safely put out the fire. I think those are the main things with ventilation and the fire strategy.
Thank you so much. And one more question from Feya Lesnivska. Ian, were the clients interested in how the avoided demolition contributes to reducing emissions, sustainability, and circular economy? Or was this a simple business venture to create an elite use of a historic building?
Yeah, that's a really good question, actually. So the driver for keeping the building was certainly at the start of the project, was the fact that it's listed. So obviously listed buildings are very carefully protected in the UK. I mean, it's a legal offence to knowingly damage a listed building. So you have to, I mean, grade 2 is slightly easier to deal with than grade 1, but you still have to be very careful, and you need permission to do whatever you're doing. So really the driver was for keeping it was to do that, and also I guess to sort of make use of the historic features and the character of the building, you know, to turn it into something that's interesting. Being honest, I guess 4 years ago when the project started, energy and carbon wasn't really on the client's agenda as such, because, you know, the sort of sad reality of it is that energy costs for a large hotel are still cheap, relatively cheap, and it's not necessarily a big driver to encourage developers to do anything better in that sense. Having said that, though, there is definitely, even in the space of the last kind of year or two, there's much more awareness from customers and guests about the environmental impact of places that they stay, and it is something that people actually ask about. So I think if we were to start this project again now, there would be more of a focus on it in that sense, because it does have a positive impact on sales and so on. But yeah, I suppose that the fact that we have retained the existing building has significantly reduced, the sort of life cycle and energy costs associated with demolishing, removing all of the waste, rebuilding it. But yeah, I guess it probably wasn't the main driver for the project originally. But there obviously are other drivers, like the fact that we have to comply with minimum environmental standards, and with the building being in Westminster, they have quite onerous energy performance targets. So we still had to meet those by using things like PVs. The building was rated BREEAM very good. And we used combined heat and power, which, although is massively gone out of fashion in the last year or two, is still actually a very appropriate solution, because it's a building that has a particularly high hot water demand, and so it works well in conjunction with that. But yeah, there was sort of no life cycle costing as such carried out, so because of no real obligation to do so. But I think that is changing, that attitude.
Thank you. One more question. Brilliant design and operation. I have to ask, how was the process of accumulating all the building data in an integrated Revit model?
Yeah, so actually it was quite painful, to be honest. It was so one of the, I guess, probably lessons learned from doing this process was, if you generate a Revit model from a detailed mesh that you've generated from a laser scan, the amount of data and memory that generates is vast, and it massively slowed down the usability of the Revit model. So the way we constructed the Revit model was the architect produced a new build model with their own coordinates, and they then brought in the surveyed Revit model, which was, I think, hundreds, if not thousands of megabytes in size. So by the time you combine the existing Revit model with the architect's new build Revit model, the structural engineers' steel and concrete Revit model, our MEP services model, and the catering consultants Revit model, which had all the cooking equipment in, you've got a Revit model that is, probably beyond what most computers can cope with on a practical level. So there was, I think, I think even in the space of time since we've done that, things have moved on, and there's ways of gathering that data in a more efficient way. There was a lot of information in the Revit model that was completely unnecessary. Like, for example, in what was the original courtyard of the building, over the time, the courtyard had grown into a sort of big wilderness, and it was like sort of almost the same height as the building. But the surveyors actually modeled that in the Revit model as well. So we had this like ridiculously detailed model of a load of grass, which we couldn't remove from the model for some reason. And it seems ridiculous, but it just made things really difficult, and there was no other way they could have done it, I don't think. So I think there's probably methods that have moved on and dealt with those sorts of things since then. But But yeah, as the design develops, obviously the model becomes more and more complicated. As you get into construction, you're starting to look at the actual installation detailing of things in the Revit, and it becomes very difficult to use. So it's definitely a sort of a steep learning curve in terms of how we do that on future projects. We didn't actually use Revit for anything beyond design coordination, so it wasn't a BIM project. We didn't include equipment or system data or anything like that, and it wasn't taken forward as a maintenance tool after completion. So that helps in a way, in that the volume of data we're working with is not as big as it would have been.
Okay, we are heading slowly towards the end. We have around 5 minutes, and we have 2 more questions. So,
okay.
Third, for the leased building, how did you balance the energy consumption with comfort? Is the digital model and BIM platform helpful to optimal the refurbishment? And I also want to follow up this question with my own. I was thinking if the thermal comfort, I guess, is a very big topic for such services, and if it was a concern, or if there was standards from the client, or did you use which kind of standards, or if there were any type of feedback that they wanted to achieve around thermal comfort? What was?
Sure. Yeah. Well, generally speaking, the thermal comfort that we achieved was good. So there's very few or almost no areas where we had any problems, and I think there was a bit of fine tuning that needed to be done to get things working. I mean, really, I guess the client looked to us to tell them what was there was nothing specific from them what they wanted to achieve. I mean, being a 5-star hotel, generally the sort of expectation is that everywhere is temperature controlled, so even corridors. But in this case, because we were limited by the constraints of the existing building, we didn't put comfort cooling everywhere, and it's probably excessive and unnecessary to do that anyway. Yeah, no, we didn't really have too many problems with that. I mean, the building itself the existing buildings were all solid masonry construction with not a huge amount of glazing, but a reasonable amount of glazing. So yeah, it was fairly straightforward to deal with that sort of aspect. The more challenging bit was actually physically fitting the equipment in that we needed to do that. Especially with the listed building and the existing structure that's quite fragile. So yeah, that was fairly tricky. I mean, there was one particular area. So there was one of the bars on the ground floor where the client was what they wanted to try and replicate was a sort of feeling of like an old-fashioned pub, sort of London pub feeling, but it was like the main cocktail bar, and we were really limited on options of where we could put the heating and cooling systems, because the glazing was the existing windows almost went to the ceiling, and there was very little space to actually drop a false ceiling in to put things like fan coil units or anything like that. So we ended up trying to conceal all of the systems into like a raised platform below the banquette seating. Unfortunately, there were a lot of issues from a buildability perspective when they actually started constructing the joinery, and it didn't really work very well, and they did have some comfort issues around there. But we've sort of subsequently, since they've opened that, we've actually managed to find a solution which involves a bit of modification to the existing joinery. But yeah, unfortunately, it was one of the sort of prime public spaces in the building. But we managed to come to a solution in the end with it. So, but yeah, that was probably the most difficult bit.
Thank you. Last question. Did you consider air quality through the process? Things as CO2 levels, relative humidity, and air changes? If yes, what was this achieved at successful levels?
Yeah, so in the bedrooms, so starting with the bedrooms, we were very keen that, again, being a 5-star hotel, the air quality is an important part of that. And historically, it was, if you look at older hotels, they don't tend to put what we call supply air ventilation. So they would put extract into the bathrooms and then just let the room be naturally ventilated either through a trickle vent or an opening window. Being a sort of city centre location, background air quality levels are quite poor. So we were very keen to push having a full supply and extract ventilation system, which was what we ended up with. But in the early stages, the client was sort of challenging us on it because it was, additional cost, additional complexity, and they were sort of thinking, well, do we need to do that? Can we not, get away without doing it? But from our perspective, it's important. In terms of the other areas of the building, I mean, it's virtually all mechanically ventilated, and because of the expectation is for it to be quite highly or densely occupied, certainly pre-pandemic anyway. It's important that we maintain good indoor air quality levels. So we didn't actually do any benchmarking or measurement, but we certainly followed, above best practice in terms of the ventilation rates that we're achieving in all the spaces. I think possibly the only areas where we did have air quality monitoring in the design is in the kitchens, and that's more of a functional requirement because you need to maintain sort of healthy environment for the staff to work in. So you're monitoring things like carbon dioxide, carbon monoxide, to make sure there's not a dangerous build-up in those spaces. But certainly, if you go, I mean, you can go into I'd say if anyone is passing by, go into the building. It is a public building in that sense that, you don't have to be staying there to go in. So you can go in and have a look, and the spaces feel kind of comfortable and fresh, and so it's that's probably the best way of describing it, really, if you want to experience it. Yeah.
Thank you so much. Thank you, Ian, for your excellent presentation. And do you want to add something?
No, that's it. Hopefully it was interesting. And my email address is on that last slide. If anyone wants to ask me anything else later on, as any questions come up, I'd be happy to answer anything. And as I said, it's a big project and difficult to cover all of it in sort of 40 minutes, but hopefully that's a bit of an insight.
Thank you, Ian, for presenting today, and please thank you all for being here and following this presentation. Please address any further questions to Ian directly. And yes, I would like also to remind that this is only the first webinar of a series of integrated building design webinars. So thank you all, and I hope to see you in the next one.
Thanks a lot, Athena.
Thanks, everyone.
Thanks.